First, we'll start off with nested cross-validation. Now, I want to kind of like throw you guys a question, which is, look, we have done a model selection. We've also done hyperparameter tuning. Let us say we chose a k-fold cross-validation as our strategy. We chose k equal to 10. And we did model performance and selection across a bunch of models. And we chose the models, right? After we got the model, we went on into do some more hyperparameter tuning. Okay? The question is, are we not cheating ourselves? Are we not talking ourselves into this point of overfitting? Because we did k-fold cross-validation to select a model. Then we came over and then we chose for the given model, we are then doing a hyperparameter tuning to further refine it, make it more crisper in the training data set predictions. Are we not overfitting through this process? Okay. And the answer is yes, to some extent. This is a relative problem. You have to feel the problem rather than just see it absolutely. Okay. So thus, there is a definite probability that we are going into the territory of trying to kind of do overfitting because we're trying to oversatisfy this training data. We chose a model also for it. We chose hyperparameters also for that. Of course, a slight variant of training data, which was the validation data. So to resolve this problem, what we're going to do is we're going to improve our way of approaching validation. We're going to use something called as nested cross-validation rather than a pure k-fold cross-validation. Now, the way nested cross-validation works is it is going to use the k-fold cross-validation, but with a twist. So there are going to be two iterations, two loops, run one after another, for us to be able to comfortably say that we are managing this overfitting better. Okay, so that is the goal. The first loop or the first iteration we're going to do is what we're going to be calling as an external cross-validation. Okay, the external cross-validation's goal is for model selection. The second one, which we are calling as the internal cross-validation, is going to help us do hyperparameter tuning. So instead of having two different stages or steps done separately, we are now trying to kind of tie them all together. We're giving them names also, referring explicitly what we are really planning to achieve. So in an external cross-validation, which is the first iteration, for, let us say, a k-folds, 5-fold cross-validation strategy that we may have chosen, what will happen is this validation block or the fold is being chosen. Obviously, the training fold is the rest of it. Is going to go straight into the second iteration where the internal cross-validation is going to be applied. So for each of the folds iteration, the internal cross-validation is applied. So internal cross-validation will run for n number of, or the k number of folds, which is the internal cross-validation loop, for it to be able to select the hyperparameter, best hyperparameter that can support a particular bias or a particular model that we want to choose. Cross-validation fold 2 comes in. Here, the second fold is used for validation. Rest of it is the training. But the moment this is being set up, immediately internal CV is also run. So what that means is I'm now getting multiple measures. One measure out of this, one measure out of this. Okay, that is the key thing to observe. I'm going to come back and address questions, but let's just finish this segment alone. Okay, so we keep continuing going on and on and on, where my external cross-validation is done with k equal to 5. So in this particular case, I've run for 5 cross-validations, but my internal cross-validation is done only with k equal to 3. So this was a conscious choice now we can make. So we are essentially getting 2 numbers out at each stage. One is for external CV, another one is for internal CV. And it is just not only 2 numbers. 2 numbers means position or whatever your measure is. It is also the fact how things performed at each of these folds is there, which means what would be the ideal model hyperparameter that is necessary in these particular phases, because that would also be passed. Okay. So what are the benefits? Benefits is we can have an out of fold prediction. So I'm going to show with some implementation for you to further appreciate. We can compare multiple model performances. Yes, that is correct. So this was the example that I took with XGBoost and LightGBM, where XGBoost, along with a bunch of hyperparameters, I will have a performance report. LightGBM, along with a bunch of hyperparameters, I'll have a report. So I can make a better choice in my model selection. Another thing we can definitely do is we can create meta features. So this is done a lot during the blending and stacking, where people will say, look, there are a bunch of features that are coming in from the original data set, but then can I have an intermediate model go in to create meta features? Which means if some of those features are grouped together in a tree, and if they can be considered themselves by looking into the feature importance scores of these tree models or ensembles, then it does help us, because then we can pass them that particular feature that was created by XGBoost or by LightGBM or Random Forest to another model, which will consume it as part of the stacking or blending. Okay. Another benefit it definitely does have, it limits the possibility that we are overfitting both in the model selection phase and hyperparameter tuning phase. And this was in fact the purpose that this double iterative approach to cross-validation was brought in. It does give you more reliable estimates, not because we changed something, but more because it gives you this plethora of options to say, look, this hyperparameter tuning gives me this kind of results for this model. This kind of hyperparameter tuning has given me this kind of results for this model. So thus we are a little bit more educated to make the right choice. Okay. So this is one example where we have some scores coming out both from non-nested cross-validation, where things are a lot more higher, you see, compared to a nested cross-validation, which is fundamentally including the hyperparameter tuning cost inside the cross-validation. So if we were to implement, maybe if you guys look at this code, you may get a little bit more connects, is that let's look at it this way, okay? So we have taken a very simple example where we said, look, I've just loaded up some data into X and Y, and I'm now creating a k-fold with different splits, meaning the fold size, one for outer, one for inner. Okay, so like the example I showed you, my inner was 3-fold, my outer was 5-fold. Okay, that's what I've done here. And then I'm just taking one model, like a random forest classifier. After that, I'm setting up some hyperparameter tunes that I wanted to do. So I wanted to play with the number of estimators within a random forest. I wanted to play with the number of max features. Okay, really simple data, but same way the hyperparams are also simple. Then following that, what am I doing? I'm setting up a search strategy. Now, today I'm showing you this grid search CV, but in technical theory, this may not cut it always, which is why in the subsequent session, I'm going to show you guys a very elaborate discussion of a very powerful method that's used in productions called the Bayesian optimization. Okay. So, but right now, without complicating it, just assume that this is a search strategy. Whether I'm using Bayesian strategy or grid search, the performances start to vary, but the idea of search strategy is needed. And what I'm essentially doing is, I'm saying, look, I'm giving my CV inner, my k-fold passing into this search strategy. Okay. So that whenever it is searching, it is doing a cross-validation internally. And what would it be looking into? It would be looking into my scoring, which is called accuracy in this particular case. And what are the parameters it will play with? These are the hyperparameters it will play with, which is the number of estimators and the max features. Okay. And which model will it tune? This model. So thus we are set up here. The only thing I need to pass extra when you play with these is I have to do refit. I don't want it to fit once into a random forest and then try to kind of run the cross-validations without refitting. I want each of the cross-validation to be refit because the data itself starts to change. Okay? Very good. So that is my search strategy where I have employed and literally made inner search for my data for finding the right hyperparameters. Okay. After I have my search strategy, what am I supposed to do? I will use my search strategy along with the CV outer, which is basically going to help me decide the model itself, overall model. And for that, I will use cross-val score. This will run k-fold cross-validation, cross-val score for the given search strategy using this particular fold, which in this case is a 5-fold. K-fold, which is k equal to 5. Okay. And then I'm printing out the results here, mean of my scores. So this is how we connect them together, where one is doing my hyperparameters based selection, another one is genuinely a model selection for the top items coming out of the search. But even here, I did not just choose the top item, closing my eye. Rather, I'm saying I want you to do some more k-fold cross validation, which is 5-fold validation for accuracy, using the best hyperparameters that came from here. Okay. So it would use multiple hyperparameters. It's not just one hyperparameter. It would use, let's say, 10 and 4 was one pair that did well. 106 pair also did well. Then it would keep all that and it would use them here as it tries to decide which is the right model for me. Even though here it is only random forest classifier only, it still needs to decide between 10 and 4 and 106. And that decision will happen here. All right. Everyone good so far? And this is very good. This is very good means many times this will help us reduce the overfit in the classical space, particularly in tabular space. You can fairly make an assumption that having this in your pipeline will help you a lot. Okay.